Hello, welcome to today's lesson, which we're learning how to solve square root and other radical equations. So a radical equation is pretty much any equation with a variable underneath the radical. So here for our first problem, I'm going to show you the example of solving for x. We have 3 plus the square root of 2x minus 3 is equal to 8. Now the first thing you always want to try to do in radical equations is try to get the radical isolated. So what that means is to get it by itself. So if we're looking at this equal sign, there's two sides of the equation. There's the left side and there's the right side. Well, if we want to get this radical isolated or get it by itself, we got to get rid of the 3 or everything that's outside of it. Notice the 2x minus 3, that is the expression underneath the radical. We cannot touch it until we get rid of the radical itself. So I'm going to subtract 3 from both sides. This reduces to 0, and I get the square root of 2x minus 3 is equal to 5. Now, the next step for any radical equation is now we need to raise both sides to the power of the index. Well, the index of this radical, since it's not stated, is assumed to be 2. So we raise both sides to the power of 2. So this, when I square the square root, those are opposite operations and cancel each other out. We have 2x minus 3 is equal to 25. And now I have a regular algebraic equation which I can solve for x now. So all I do is I'm going to add 3 to both sides. Get 2x is equal to 28. And then divide by the 2, the coefficient of x. Those reduce to 1, so I have 1x, or just x, which is what we want, is equal to 14. Here's a problem that I'd like for you guys to try. Go ahead and pause the video, work it out to as far as you can get, and then press play when you're ready to see the solution. Okay, so the first thing I want to do is get this radical by itself. So I'm going to add 5 to both sides. Notice not 6, 5. So now this cancels out and I have the square root of 4x plus 1 is equal to 5. And then I want to raise both sides to the power of the index of my radical, which is 2. So I square both sides. This cancels out the radical or eliminates it. So I have 4x plus 1 is equal to 25 now. And now I can just solve for my x like I would any other regular equation. So I'm going to subtract 1 and I get 4x is equal to 24. And then I'm going to divide by the coefficient 4. And so when I do that, I get 1x, or just x, is equal to 6. And there's my solution. The next type of equation that we're going to look at is also a form of a radical equation, but it's given to us in exponential form. So if we have x to the power of m over n is equal to k, the way that we would get rid of this exponential equation is we would raise it to the power of the reciprocal of its exponent. So if we were to do that, we would raise both sides to the power of the reciprocal of m over n, which would be n over m. And we do that to both sides. And remember, when I have a term with an exponent raised to another power, we multiply the exponents together, and what happens when we multiply reciprocals together is they cancel each other out. So these would reduce to 1, and we'd have x to the first power, which is just x, and it is equal to k to the power of n over m. But when we do this, here's a little property that we have to make sure. When I have x to the power of m over n, and either m or n is even, we have to say this is equal to the absolute value of x. So here's an example showing you that previous property. So again, the first thing that I want to do is I need to isolate the term with the rational exponent, just like I isolated the radical in the previous example. So I'm going to get rid of that 3 by dividing 3 to both sides. And I get x plus 1 to the power of 2/3 is equal to 4. And then now I have this term isolated, and I want to get rid of its exponent, or rational exponent. So I take both sides to the power of its reciprocal, which is going to be to the power of 3/2. Okay, now when I have these, all I need to do is I multiply these exponents, and remember, when I multiply reciprocals, it reduces to 1, so I have x plus 1 to the power of 1, which I don't need that, so it's just x plus 1 is equal to the 4 to the power of 2/3. Now, remember, when I raise x to the power of anything that has a either even numerator or denominator, if either one of these are even, I have to create an absolute value here. Okay? So now, if I go to the 4 to the power of 3/2, this is the same as taking the square root of 4 raised to the power of 3. Well, the square root of 4 is 2, and 2 to the power of 3 is 8. And so now I have another equation here. Remember, if this is x plus 1, the absolute value of is equal to 8, it could be x plus 1 is equal to 8 itself, or x plus 1 is equal to a negative 8 as well. And so now to solve this, all I have to do is subtract 1 from both sides. And 8 minus 1 is 7, so x could equal 7. Or, if I do negative 8 minus 1, I get x could also equal a negative 9. Now, I want to go ahead and check both of these solutions to see if they come out correct. So if I have 3 times x plus 1 to the power of 2/3 is equal to 7 here, or 12 I mean, and I'm replacing that x with 7, so it would be 7 plus 1 there, I would get 3 times 8 to the power of 2/3 is equal to 12. 8 to the power of 2/3, if you evaluate that, would be 2 to the power of 2, which is 4. So we could have 3 times 4 is equal to 12. And we know 3 times 4 is 12, so that is a true statement. So x equals 7 is a viable option. So let's look at the other one, negative 9. So if we have 3 times negative 9 plus 1 to the power of 2/3 is equal to 12. Let's see if this will work. So negative 9 plus 1 is negative 8. Negative 8 to the power of 3, or 2/3. Again, that's the cube root of negative 8, which is a negative 2. And that's going to be squared, which is also a positive 4. So 3 times 4 is 12. So again, 12 equals 12. That is also a viable solution. So both x equals 9 and x equals 7 are solutions that will work. Here's a problem that I would like for you guys to try on your own, and then after pausing this, try this on your own and then press play once you're ready to see the solution. Here's a hint first. Go ahead and change this expression into an exponential function. So this, get rid of the radical and change this into an exponential equation. Okay, so the first thing that I want to do is, like I said, I'm going to change this into a rational exponential equation. So it's going to be x plus 1, and the numerator is going to be 3, and the denominator is going to be the index. So we'll have x plus 1 to the power of 3/5. And then we still have plus 1 is equal to 25. Now I want to get rid of everything except for this term, so I'm going to isolate that. So I'm going to subtract 1 from both sides. So I have 3 times x plus 1 to the power of 3/5 is equal to 24. Then I'm going to divide both sides by 3. And I get x plus 1 to the power of 3/5 is equal to 8. And now that I have both sides, or I'm sorry, not both sides, but I have the expression or the term that's being raised to the rational exponent isolated, I can raise both sides to the power of its reciprocal, so 5/3. 5/3, oops. So 5/3, and again, these reduce, and now that these are both odd numbers, I do not need to write my absolute value. So I just have x plus 1, and then if we take 8, the cube root of 8 to the power of 5, well, the cube root of 8 is 2, so 2 to the 5th power is going to give me 32. And now I just solve for x by subtracting by 1. So I get x equals 31. Alright, so here's one last example, and we're going to label this check for extraneous solutions. Now, a lot of times, or sometimes when we are dealing with radical equations, we can get what's called an extraneous solution. We do the math, we find out, and we get an answer. And we've done the math correctly. But if we were to plug that solution back into the equation, we would get an untrue statement, which would be an extraneous solution. And an untrue statement would be something like 3 equals 5. You know that's ludicrous, so that can't work. 5 equals 5 is a true statement, and so that would mean that if we got something like that, it is a viable solution. So let's show you kind of what an extraneous solution might look like. Now, if we follow the steps, we would first get this radical isolated, or by itself. So I'm going to add 5 to both sides. And so I have the square root of x plus 7 is equal to x plus 5. Notice now that I have a variable on the outside of the radical also, when I square both sides here, now I have a binomial squared. This side just reduces like it would normally, but now I have to do x plus 5 quantity squared. So now normally I would use the FOIL method because x plus 5 squared is x plus 5 times x plus 5. And so I would do the first outside, inside last, and you would get a polynomial, trinomial. Well, here's a simplified version. To do binomials squared, we could do the first term and square it, so x squared. Then we can multiply the two terms together, so x times 5 is 5x. It's a positive 5x, and we double that, so multiply it by 2. That would be 10x, so plus 10x. And then we square the second term, so 5 squared is just 25, and that is the trinomial that we would get by squaring the binomial x plus 5. Now we have a quadratic equation here. So what I need to do first is I need to put this into standard form, so I need to bring the x and the 7 to the other side. So what I do is I'm going to subtract x from both sides and subtract 7 from both sides. When I do that, I get 0 is equal to x squared plus 9x plus 18. And now I need to find factors of this trinomial. So I'm going to try to factor out that trinomial. Remember, when I factor out a quadratic trinomial, it's going to be the product of two binomials. Factors of x squared, or x and x. Now I'm going to be looking for factors of 18 that will add to be a positive 9. Well, plus 3 and plus 6 are going to be my two factors. 6 times 3 is 18. 3 plus 6 is 9. So there's my two factors. And now once I have factored it out, I set both factors equal to 0. And then I'm going to solve for the x. So I'm going to subtract 3 here and I get x equals negative 3. Subtract 6 from this side and I get x equals negative 6. So now I have two solutions. But I need to check and see if these are the correct solutions. Excuse me. So what I'm going to do is take a look at our original equation, which was x plus 7, or the square root of x plus 7, minus 5 is equal to x. So if I plug in the negative 3 into that equation, I will get negative 3 plus 7 minus 5 is equal to x, or I'm sorry, I replace the x with negative 3. And now I go through and do the work. Negative 3 plus 7 is 4. The square root of 4 then is 2, so I have 2 minus 5 is equal to negative 3. 2 minus 5 is negative 3, so that works. So that is a good solution. Now we need to do the other x. So let's see if we plug in negative 6 into the x, will we get a true statement? So negative 6 plus 7 is 1. The square root of 1 is 1. So I have 1 minus 5 is equal to negative 6. 1 minus 5 is a negative 4, which is not equal to negative 6. So we know that this is not a true statement, so x equals negative 6 is an extraneous solution. Alright, so here's another equation I'd like for you guys to try on your own. So press pause and try to solve this as far as you can get, and then once you're ready to see the solution, press play. Alright, so now the first thing that I'm going to do is isolate the radical, so subtract 3 from both sides. So I get the square root of 5x minus 1 is equal to x minus 3. And now I have it isolated, so I'm going to square or raise both sides to the power of the index, which is 2. These cancel out. I have 5x minus 1 is equal to, and using that method I showed you guys, I square the first term as x squared, multiply the two together, so that's going to give me negative 3x, and I double it, so that's going to give me negative 6x, and then I square the second term. Negative 3 times negative 3 is a positive 9. And now I need to get this in standard form, so I do that by setting everything equal to 0. So I'm going to subtract 5x from both sides and add the 1 to both sides. So when I do that, these cancel out. I have 0 is equal to x squared minus 11x plus 10. And I need to factor out this trinomial now. So I get 0 is equal to x minus 10 and x minus 1. Negative 10 times negative 1 is a positive 10. Negative 10 plus negative 1 is negative 11. So now I know that I can set these equal to 0, each factor, and solve for the x. And I get x equals 10 and x equals 1. So let's see if these are extraneous. So I'm going to go back to my original equation. That's not it. Let's look at this one. I think there we go. So I have the square root of 5 times x, well if x is 10, that's going to be 50, minus 1, plus 3 is equal to x, which would be 10. So let's do this. 50 minus 1 is 49. The square root of 49 is 7, so I should have 7 plus 3 is equal to 10. And we know that 7 plus 3 is equal to 10, so that solution works. And x equals 10 is a viable option. So let's try x equals 1 now. So if we plug it back into this equation, we have 5 times 1 is 5 minus 4. So it would be 5 minus 1 plus 3 is equal to, and it should be our x, which is 1. 5 minus 1 is 4. The square root of 4 is 2. So I have 2 plus 3 is equal to 1. Well, 2 plus 3 is 5, which is not equal to 1. So that is not a solution. So this is extraneous. And our only solution is x equals 10.